Alright, this is the notes for section 8.3, properties of inverse functions. So what we want to do is we want to look at what we know about a function and its inverse, and how we can tell if functions are inverses of each other. Kind of the big idea surrounding that is that the composite of a function, so if I look at any function and its inverse, so function and its inverse, and I do the composite of that, it will always be in either order. It's always going to be the identity function. Okay, so we'll look at what that looks like here in just a little bit. Now, before we do that, let's first understand how we write inverses as it relates to functions. So if we have any function, we'll call it f of x, and we know that that function has an inverse that is also a function. When we write this function, we will write it like this: f inverse of x, and so f to the negative first power of x. So that raising something in the negative first power kind of indicates inverse. So what I'd like to do next is I'd like to go through the process of how do we find the inverse of a function and write it as a function, if it is. And these are the steps that we're going to do. So we'll start with the original function. We're going to take out f of x and replace it with y. Then we're going to switch the x and the y. And then, so this is the stuff that we did last section. We switched the x and the y, and we just kind of stopped there. Now we're saying, well, if the inverse is a function, we should be able to write it in that function notation. So what I'm going to do then is I'm going to solve this new equation for y, and then I'm going to rewrite, I'm going to take y out, and in its place I'm going to put f inverse of x. So that's kind of the process that we're going to use today as we go through that. Okay, so let's take a look at it. First of all, let's replace f of x with y. So if I do that, I have y equals 1 over 2x. Now what I'm going to do is I'm going to take my x value and my y value, and I'm going to switch those. So if I do that, so I'm just taking where the x and y are and just switching them, so we have x here and y here. Now I have y down here, and what I have to do is I have to use my algebra skills to solve this for y. So that's kind of where your real work comes into play. Alright, so here's what I'm going to do there. The first thing, I have y on the bottom, so the first thing I have to do if I'm going to solve for y is I got to get it off the bottom. So I'm going to multiply both sides by y. Okay, if I do that, on the left side I'm going to get xy, and on the right side I have 1/2. Okay, now if xy equals 1/2 and I want to solve for y, the next thing I have to do is get rid of the x. I'm going to divide both sides by x. Now if I divide both sides by x, xy divided by x, my x's are going to cancel out, and I'm left with just y on the left hand side. And over here, if we think about our rules for fraction, if I have a fraction divided by a number, I'm going to take that number and I'm going to invert it and multiply it. So that's like kind of like x over 1. So if I flip that over, it's like I'm multiplying by 1 over x. Therefore, I get 1 over 2x. So in other words, y is equal to 1 over 2x. Now the last step that we have to follow is we need to substitute in f inverse of x for y. So that's all we have to do to finish this off. And we now have it in function notation, and we found the inverse of f. So that's the process that we use. So let's see if we can do that with this example problem here. You might want to pause it and just see if you can do it. It doesn't matter that it's in mapping notation instead of function notation. The process is still the same. Why don't you pause it, see if you can do it, and then I'm going to put the answer in here. Alright, so here's what you would get on that one. We're just going to take the function notation and replace it with y. I'm going to take my x and my y and switch where they are. Here's x, here's y. I'm switching them. Now the process is solving for y. So what I did is I multiply both sides by 2, get the 2 off the bottom. Now I'm going to go ahead and distribute here to get 2x equals 4y plus 25. Now I'm going to divide, I'm going to go ahead and subtract 25 and then divide by 4. So I get y by itself. Now I'm just going from here to here, I'm just simplifying that. So I'm saying y equals, this is 2x over 4, which is 1/2 x, and 25 over 4. Okay. Now I'm going to finally write it in h inverse of x. I should have an x there, sorry about that. H inverse of x equals 1/2 x minus 25 over 4. Alright, so now we know how to find the inverse of a function, write it in the correct notation. So the last main thing that I want to be able to get across to you in terms of a function and its inverse is the inverse function theorem. And it's a really important one. You might want to star or highlight this, because if I want to show that two functions are inverses of each other, I have to use the inverse function theorem to do it. Okay, and all the inverse function theorem says is this: if I have two functions f and g and they're inverses of each other, the only way that that can happen is if I take the composite of those two functions in either order, it will always be equal to x. If that happens, then the two functions are inverses of each other. Okay, so let's take a look at this example here. I have two functions, 12x minus 4 and 4 plus x over 12, and I want to see if those two functions are inverses of each other. The way I do it is I do g of f of x and f of g of x, and I want to see that they're both equal to x. And as you can see, if I do the composite of those two functions, I get, in both cases, I get x. Okay, and since g of f of x is equal to f of g of x is equal to x, the functions f and g are inverse functions of each other. Okay, so if you're asked to show that two functions are inverses of each other, this is the process that you're going to use. You're going to show that this statement is a true statement. All right, so the last thing I'd like to take a look at is the power function inverse theorem. So if you think back to chapter 7, we looked at a power function, and then we also looked at roots. And we can do a root function as well. Well, all the power function inverse theorem says is that a power function x to the n and a root function x to the 1 over n are inverses of each other as long as the domains of f and g are the non-negative real numbers. Okay? If that happens, then we can say that they are inverses of each other. So notice how the important thing here is that set of non-negative real numbers. So for instance, if I had taken and I had included the negative numbers over here, then the inverse of it would not be a function. Okay, so here is an example where it's the non-negative numbers. Here's all the set of all real numbers. This is the inverse of h is not a function here, whereas it is here. So these are inverse functions of each other as long as the domain of both functions are limited to the non-negative real numbers.